Welcome to The Explainer. Today, we're diving into one of the biggest, most mind-bending questions out there. Are we all just living inside a giant computer simulation? And what if the answer wasn't in some complex theory, but in something as mundane as an electricity bill? You know that feeling, right? Maybe you're just going about your day, and for a split second, something just feels off. A little too weird, a little too perfect. You get that strange little thought, what if none of this is actually real? Yeah, exactly like that. Like we're all just characters in a cosmic video game. But here's the thing. This isn't just a fun idea from movies anymore. It's a serious scientific debate called the simulation hypothesis. And for a while, it seemed like we might actually be able to prove it. So let's get into this seductive idea, because for a time, it really felt like we were on the verge of finding the answer. The whole plan was to try and spot a glitch in the matrix, to find the seams in our reality. It all kicked off back in 2014 when a physicist named Silas Bean and his team published this paper that got everyone buzzing. They proposed a real, actual scientific method to catch the creators in the act. Okay, so here's the core of it. Any computer program has a limited resolution. Think about your computer screen. If you get close enough, you can see the individual pixels. Well, the theory is that our universe might be the same way, that space-time itself isn't perfectly smooth, but is made up of a grid of these tiny fundamental units. All right, so how on earth would you even begin to look for these cosmic pixels? Well, Bean didn't just drop this idea on us. He actually gave us a roadmap, a 3-step plan to hunt for the glitch. The plan was kind of brilliant. You look for the most powerful particles zipping across the universe, these things called ultra-high-energy cosmic rays. Because they have so much energy, they should be able to feel the tiny gaps in this cosmic grid. So if space really is chunky, these particles wouldn't fly in a perfectly straight, smooth path. They'd scatter in a weird, lopsided way. And if we saw that, bingo! That's the edge of the simulation's pixels. I mean, how cool is that? It's an incredible idea. But just as we're all getting ready to pick the red pill, a very recent study from an astrophysicist named Franco Vazza comes along and basically throws a giant bucket of cold, practical water on the whole thing. And this is where the whole debate takes a sharp turn. Vazza's research built this powerful counter-argument by shifting the question entirely. He stopped asking, is it possible, and started asking, yeah, but who could afford to run it? What Vazza did was just brilliant in its simplicity. He actually sat down and calculated the computing power, the energy, the RAM, the whole shebang it would take to actually run a simulation of our universe. He brought this amazing sci-fi quest crashing down to a very sobering, practical reality. And the results, well, they're staggering. A full high-res simulation of everything turns out to be fundamentally impossible. To run it, you would literally need more energy than exists in our entire known universe. Oh, and the hard drive just to store the initial startup file, it would have to be bigger than the universe itself. So, yeah, that's a bit of a problem. Okay, so a full one-to-one simulation of everything is clearly off the table. But what if the creators were smart about it? What if they cut some corners to make it cheaper to run? Vazza thought of that too. He calculated what it would take if the simulation was just focused on us, just our little blue marble, with the rest of the universe rendered as a low-res background. Even then, the numbers are just, well, they're astronomical. To give you a sense of scale, just booting up the program to simulate Earth, just the startup sequence, would require the energy equivalent of 330,000 suns all going supernova at the exact same time. That is a heck of a power-on button. And what about the computer you'd need? Forget building it in a lab. We're talking about a machine the size of the planet Jupiter. And it would run so hot, hotter than the core of our sun, that any material we know of would just instantly vaporize. You couldn't even build the thing. Vazza even considered a low-res model, one that only renders things when we look at them, like a video game. But even with those shortcuts, a supercomputer powerful enough to do the job would still take 100 million years just to process a single second of our reality. The lag would be noticeable. So, based on the laws of physics as we know them, a simulation of our world just seems impossible. Case closed, right? Well, this is where Vazza leaves us with one final, absolutely mind-bending twist. The conclusion from all this number crunching is pretty clear. The energy cost alone makes a matrix-style simulation a non-starter. You couldn't even power it up, let alone run it for billions of years. But here's the loophole.
Vazza calls it the Pac-Man analogy. Think about it. Pac-Man is inside his game. He can learn the rules of his little maze, he can figure out the ghosts. But what he can never, ever do is understand the circuit board, the power cord, or the arcade cabinet he's living in.
And that's us. We're Pac-Man. All of our calculations, all of our physics are based on the rules we see from inside the maze. If our creators live in a different kind of universe with totally different rules, a place where maybe energy is free or computing is infinitely cheap, then all our calculations are meaningless. We're using our physics to judge their technology, and we can't do that.
So where does that leave us? Based on our understanding of physics, we can be pretty confident our reality is the real deal. The cost is just too high. But there's always that little question. What if the creators aren't playing by our rules? What if they have a cheat code for the universe itself? What do you think?